Hello. Today we are going to work through proof that the power rule works for all rational exponents. Okay, so a rational number r can be expressed as an integer p divided by an integer q. That is true because a rational number r times 10 to the n, where n is the number of digits after the decimal place, divided by 10 to the n, is going to equal, both of those are going to be an integer. Both of those are just going to be an integer. Okay, so this is true, and in the last few videos I have proved the power rule for positive and negative integer exponents. So now let's take a function that y equals x to the p over q. Now let's try to take it to derivative. Okay, so what we want to do is we are going to raise each side to the q. So that's just going to be y to the q is going to equal x to the p. Okay, now, as you may remember from the last video, I did implicit differentiation, so we can use that here. Okay, so let's take it as y to the q minus x to the p is equal to 0. Okay, so let's rewrite that, or let's just take the derivative of each side. So that's going to be y prime times qy to the q minus 1 minus px to the p minus 1, and the derivative of 0 is just 0, so okay, so now let's take the so now let's just add px to the p minus 1 to each side. So now it's going to be y prime times qy to the q minus 1 equals px to the p minus 1. And now we want to get the derivative of y prime by itself. So let's divide each side by qy to the q minus 1. Okay, so let me switch colors. Now we have that y prime equals px to the p minus 1 over qy to the q minus 1. Okay, so that's pretty good. But now we want to get this all in terms of x, so let's go back up here. Y is equal to x to the p over q, so let's just substitute that in. So let's use that here. Oh, I'm sorry, that line must be a mistake. Okay, so we have y prime is equal to px to the p minus 1 divided by q x to the p over q raised to the q minus 1. Okay, so that's just get rid of this p over q. Well, not get rid of it, we're just going to break it off. So it's going to be p over q. This is so y prime equals this multiplied by x to the p minus 1 over, now we're going to have x to the, now that's just going to be multiplied by it because it's to that power. So we're going to have to the pq minus p over q, and that's the exponent. Okay, so as you may remember from algebra, a number k to the m over k to the n is just equal to k to the m minus n. That should make sense. So now let's do that here. So now we have that y prime is equal to p over q times going to be x to the a. Now let's work with a, so we don't have to have all these x's and p's and q's over here. So we're going to have that a equals p minus 1 minus, it's going to be pq minus a negative is just a positive, so minus or plus p, and this is going to be over q. It's all going to be over q. And so it's not minus this. So now let's multiply q by this, so it becomes, oh sorry, keep doing that. So that's going to equal pq minus q over q. Then we could have everything over q minus pq plus p. Remember, like, minus a negative is just a positive, so we can cancel those because it's minus a plus, so it's now negative q over q plus p over q. That's just going to equal negative 1 plus p over q, or just p over q minus 1. So that's what a is equal to. So a equals p over q minus 1. Okay, so let's go back up and substitute that in for this. So you're going to get that y prime, the derivative, is equal to p over q times x to the p over q minus 1. And that is just the power rule, because remember the exponent was p over q. So as you can see, we multiplied by that exponent, and x now to the power, that power minus 1. Okay, I hope you learned something in this video, and please come back next time where I will be working through a proof of the product rule. Okay, thanks for watching.